There we go. So from this assignment, I'm going to be going over page 318, numbers 32 to 35, 326, 19 through 24. And on page 318, number 32 starts like this. It is 4x squared minus 8 equals 0. We're just trying to solve this by the method of your choice. Considering that there is no x term here, I think that the easiest way to do this would just be to get x squared by itself, right? If you were to get x squared by itself, you could do that by adding 8 to both sides, leaving you with 4x squared equals 8. Divide both sides by 4. And you'll have x squared equals 2. So x squared equals 2 doesn't have any rational solutions. However, at least they're real. The roots to this would be x equals the square root of 2 and also negative square root of 2. So those are the solutions there. Number 33. Number 33 says 4x squared plus 81 equals 36x. Okay, now this one I got questions about during class. Full disclosure, I'm not working out of the teacher's edition. I'm just working out of the regular old textbook, which means I'm solving these problems myself right in front of you. So if I go down a blind alley, it's just, I guess, for everyone's benefit, or at least that's how I'm going to spin it. No, I didn't make a mistake. I was teaching you. So first thing I want to do is I want to turn this into standard form. That means I'm going to subtract 36x from both sides. And I want to see if this is factorable, because I've got 4x squared minus 36x plus 81 equals 0. So in order for this to be factored, I'm going to need to come up with some options, because usually the way that factored things go is it's x minus or plus something times x minus or plus something. However, since there's a 4 here, I've got options for what to put there. And since there's an 81 here, I've got options for what to put there. And I need to come up with some options that are not only going to give me 4 and 81, but are also going to give me negative 36. So all of this is just to avoid the quadratic formula. Behold thy doom. Opposite of b plus or minus the square root of b squared minus 4ac. Oh, well, that's actually not that hard at all. Oh, my bad. Well, I'm still going to try to factor it because I'm trying to teach you something. Over 2a. That actually might be solvable. It looks like the answer is 36 over 8. But, let's not give it away here. If you were to try to factor this thing, you would need to come up with a pair of factors that make 4 here and make 81 there. Here's how you make 4. You can make 4 by doing 1 times 4, or 4 times 1, and 2 times 2.
Well, what about 2 times 2?
Yes, also 2 times 2. In order to get 81, sorry, the reason I wrote both of those is because it matters which one it goes in, but if it's 2, then, it's the same. So 81, you can get 81 by doing 1 times 81, or 81 times 1. You can get it by doing 27 times 3, or 3 times 27. And you could also get it by doing 9 times 9. Unfortunately, that means 3 times 5. There's 15 possibilities. And to write them all out would be kind of annoying. Just to show you what I mean, this one, let me just arbitrarily pick that one. 4 times 1. You see how there's 4 and 1? And then let's just pick one here. The 27 and 3. Yeah. Plus 27 plus 3. If you were to FOIL this, you would get 4x squared plus 81. And in the middle, you'd have 12 plus 27, which is 39. Oh, so close. Except it's also positive. So you know what? Forgot, in order to get negative to 4, you could also do -1 times -4, and -4 times -1, and -2 times -2. And oh my gosh, it wasn't actually 15 of them. It was 30 of them. Trying all those is exhausting. So, when you get to a point where the shortcut is not a shortcut, you stop taking the shortcut. However, since I tried the quadratic formula and noticed that, that tells me that actually vertex form would have been a really good move.
Wait, so if the shortcut isn't the shortcut, when then technically make the normal way the shortcut?
Yeah, when I say the shortcut isn't the shortcut, what I mean is what seemed to be the shortcut was actually the long way. Then you abandon it as a false start. This indicates that vertex form was actually correct, and here's how I can tell you that. Because this is the square root of 0, it means that the plus and minus is gone. And that means there's only one answer instead of 2, which means its vertex is on the axis. I'm going to try this one more time in vertex form. I need a new sheet of paper because I'm actually out of room. I'm going to do this one more time, but in vertex form. Number 33. One more time. It's 4x squared minus 36x plus 81 equals 0. I'm just going to make this a little tidier. I'm going to subtract 81 from both sides, and it'll help get my mind in the right place to complete the square. All right, so if we're going to complete the square, it might also help to factor out a 4. 4 times 9 is 36. What is half of 9? 4.5. 4.5 squared is 20.25. If this were 4 of x squared minus 9x plus 20.25, it would be a square. But the problem is, in order to account for that, I need to have a minus 20.25. 20.25 times 4 is 81, which means I need to have a minus 81 here. Wait a minute. That's see? It's just there. If we had divided this whole thing by 4, or a factor to 4 out, we would have gotten this. That 4 doesn't matter because this is the only thing that can turn into 0. That's x minus 4.5. So the only answer that will work is x equals 4.5. Back to the quadratic formula version, it was 36 over 8. Is that equal to 4.5?
No.
Yes. 36 over 8. That's 32 plus 4 over 8. 4.5. And I love it. I don't know.
That was kind of cheesy.
Yeah, it sure was. But I'm not above that. All right, so the answer is x equals 4.5. That's the answer to number 33. All right, so I said that I would do 32, 33, 34, and 35. So I better get going on number 34. Number 34 says negative 4 of x plus 2 squared. I'm sorry, plus 3 squared. X plus 3 squared equals 28. Now, if we were to try to do this the simple way, that is to get x by itself, the first thing I would do is I would divide both sides by negative 4. That's the first thing I would do. If you do that, you end up with x plus 3 squared equals negative 7, which is difficult to do math with. But we're in Algebra 2. This is the big leagues. It's at least the minor leagues. So let's see what we can do with it. If we were to take the square root of both sides, you'd have x plus 3 equals the square root of negative 7. That is an irrational imaginary number. It's I times the square root of 7, but like, pick your poison. And then you can just subtract 3. X equals, I suppose that should also be the plus or minus square root of negative 7. So we got x equals negative 3 plus or minus I root 7. There's your two answers. Negative 3 plus I root 7 and negative 3 minus I root 7. They're complex, irrational answers, but it's Algebra 2. We can do it. All right, I might have enough room to squeeze in 35 on this sheet. Yeah, I think I could probably do that. I'm going to give it a shot. If I can't, then oops. Number 35 says 3x squared minus 10x equals 7. Okay, so now that we've got that, I'm noticing prime numbers. I like prime numbers because it's really easy to find the factors of prime numbers. So I'm going to subtract 7 from both sides. If you do that, you've got 3x squared minus 10x minus 7 equals 0. If this is factorable, it will look like this. 3x something times x something. Because there's only one way to get 3, and that's 3 times 1. So the question is, what about 7? The only way to get negative 7 is negative 7 times positive 1 or positive 7 times negative 1. If we had the 3 opposed with the 7, we'd have 21. We'd be so far away from 10, it would be hopeless. So the only possibility is 1 here and 7 there. And one of them needs to be negative. If the 1 is negative, Then it's 3 times, all right, so negative 3x. Then it's plus 7. Yeah, okay. So, yeah, they're going in opposite directions. So we need that to be addition. Or not addition. We need them to go together. So here's the problem. In order to make that negative, I need them to be the same. But in order to get that to be negative, I need them to be different. They can't be the same and different at the same time. It's a dead end. There's no way to get that. In fact, I bet that if we graphed this, we'd find it doesn't even have any x-intercept. So I'm just going to have to go ahead and do the quadratic formula. I doubt that I have enough room to do that here. I am going to give it a shot. If I shift it up, maybe I can get a little extra room out of there. Opposite of b, plus or minus the square root of b squared minus 4ac over 2a. Oh, wait, no, that doesn't look like it's going to be imaginary at all. 100, let's see, 4 times 3 times negative 7. 4 times 3 times... Yeah, 184. So this is... well, that threw me for a loop. 10 plus or minus the square root of 184 over 6. Well, that's certainly irrational. 184, that looks divisible by 4. Yeah, 46. So, boy, I really am using up about all the room that I have. If I were to rewrite, I'm going to rewrite this over here. So I got 10 plus or minus root 4 times root 46. So that's a 2 I can cancel out. And so I've got 5 plus or minus the square root of 46 over 3. Can 46 be broken down? 46 isn't divisible by 9. It's not divisible by 4. It's not divisible by 16. It's not divisible by 25, no. Well, that looks like the answer's there. 5 plus or minus root 46 over 3. Yikes, didn't see that one coming. I thought between the 3 and the 7 and the 10 it would have been factorable. So yeah, that won't have any whole number solutions. Nothing easy about that at all. All right, well, the next problem set that I need to work on is page 326. I'm going to do a few problems from there. I'm actually going to do 19 through 24. Doing well on time. Page 326, numbers 19 through 24. All right, so let's start with 19. So number 19 says, yeah, that's on camera. Number 19 is y equals negative x squared minus 4x plus 8. So this is vertex form that we're looking for. We want to put it in vertex form, then identify the vertex, axis of symmetry, and direction of opening. Just for our reminder, this is vertex form. Vertex form contains the vertex, which is the point HK. The axis of symmetry is the line x equals h. And the direction of opening depends on A. If A is positive, it's concave up. If A is negative, it's concave down. So let's see what we've got. I think it's pretty clear from this that A is negative. So I'm just going to factor a -1 out of it. And maybe that'll help move on. Y equals negative of x squared plus 4x minus 8. So half of 4 is 2. 2 squared is 4. So this should say plus 4. If this were to say x squared plus 4x and then plus 4, but instead it says minus 8, then I need to put a minus 12 there. You see how plus 4 minus 8 is, I'm sorry, plus 4 minus 12 is the same thing as minus 8 from up above? Okay, so that minus works out to be like this. Just so you're clear, that negative sign distributes to that negative 12, makes it positive 12 outside. This is x plus 2 times x plus 2. Like that. That's pretty much vertex form. If you wanted to be picky, say it's supposed to be a minus, then you could say, all right, fine. Y equals -1, right? X minus -2 squared plus 12. Fine, now it's in vertex form. Are you happy? No, that looks hideous, but at least between the two of them, that's vertex form. H is -2. K is 12. A is -1, which means if H and K are these values, then the vertex is -212. The axis of symmetry is the line x equals -2, and it opens down. Without even seeing a graph of it, I already know what this thing is going to look like. The vertex is slightly to the left and up quite a bit, like this, and it opens down. That's what the parabola looks like. Okay, well that was number 19. I've got some more to go through, and hopefully I can do it in the time allotted. Yes. Because there's a negative sign there. That represents A. Here A is -1. Yep. All right, so that was number 19. Now I'm going to do number 20. If I can pick this paper up. All right, number 20. Y equals x squared minus 6x plus 1. Let's see if I can fit two problems on this one piece of paper. Number 20. Y equals x squared minus 6x plus 1. This looks like a simple case of completing the square. If this were x minus 3 squared, it would be x squared minus 3x plus 9. That's not a plus 9, but it is a plus 9 minus 8. So this part of it can be factored into, oops, not x plus. I'll just put -3 then. So x minus 3 squared, sorry, I wrote plus instead, minus 8. Notice there's nothing in the front of it, right? So in vertex form, it's y equals x minus 3 squared plus -8. I'll do that because it's supposed to be plus k. So we got our values, okay? H is equal to 3, not -3, it's equal to 3. k is equal to negative 8, and a is equal to 1. So this thing opens up, and it has its vertex at the point 3, negative 8. It has an axis of symmetry of x equals 3, and it opens up. Here's number 20. '21 coming up. 21 says y equals negative 3x squared plus 12x. All right, so to complete the square on this, like, we just need to add something in that's going to make it work. Before that, though, I want to uncomplicate this by factoring a 3 out. Actually, a negative 3. That complicates things having 3's on there, because now I can just focus on what's half of negative 4. This is a lot like number 19, actually, where we had a minus 4x, and we needed it to be x plus 2, except x plus 2 squared has a plus 4 in it. So, if this were negative 3 of x squared minus 4x plus 2 minus 2, I'm sorry, not plus 2 minus 2, plus 4 minus 4. So I'm thinking 2 squared. This is x plus 2 squared. That negative 3, that negative 4, distribute, make a plus 12. So I'm looking at negative 3 of x minus 2 squared plus 12. X minus 2 is the square root of x squared minus 4x plus 4. That minus 4, I actually have minus 3 of them. That's why there's 12 outside. So, x equals 2. I'm sorry, not x. H equals 2. K equals 12. A equals negative 3. Which means we have a vertex of 212. An axis of symmetry of x equals 2. And it opens down. Hey, we can even fit more on this piece of paper. We've got less than 10 minutes left. 22, 23, 24. 3 problems to do. Ooh, let's see if it can be done. If we didn't spend so long talking about the ethics of teacher YouTube relations. And anyway, number 22 says y equals 4x squared plus 24x. We basically have the same situation as we did in number 21, in which I can factor out a 4 to clear my head. Say, what's half of 6? It's 3, so there ought to be a 9 here, but there's not allowed to be a 9, so like that. And plus 9 minus 9, 9 times 4 is 36, so this is 4 of x plus 3 squared minus 36. So that's plus 3, which means h equals negative 3, because after all, y is equal to 4 of x minus negative 3 squared plus negative 36. I don't know how picky to be. H is equal to negative 3. K is equal to negative 36. And A is equal to 4. Which means I've got a vertex of, oh, that's actually out of the view because of this.
Why would it be minus 36?
It's minus 36 because that's minus 9. In order to get this square completed, so I start out, all right? I may have been hasty. Okay, good. Um, I'm going to repeat it, though, just because I started the explanation. It's recorded. You factor the 4 out. That 4x squared turns into x squared. 24 turns into 6. Half of 6 is 3. To square 3 is 9. But in order to keep it equal, you need to subtract the 9. It's like a magic trick. My thumb is shrinking. And then when you distribute the 4 into that minus 9, it turns into minus 36. Anyway, that's the equation in vertex form. Speaking of vertex, here's the vertex. The vertex is the point negative 3, negative 36. The axis of symmetry is the line x equals negative 3. And it opens up. All right, 5 minutes left. This is definitely all we're doing today. Number 23 is y equals 4x squared plus 8x minus 3. So to put this in vertex form is another, complete the square kind of a problem. To factor a 4 out of there would be a little tricky, but I mean, we'll have a fraction before or later. I guess I'll just have it now. If you factor out a 4, then this is equal to 4 of x squared plus 2x minus 3/4. Interestingly, half of 2 is equal to 1. So this should be a 1. But this is minus 3/4. So if we do plus 1 minus 1 3/4, then we'll have it 4 of x squared plus 2x, and now here's the completing the square bit, plus 1 minus 1 3/4, which is 7/4. Well, 4 times 7/4 is 7. So we're looking at 4 of x squared plus 2x plus 1. That's x plus 1 squared. And then 4 times negative 7/4 is negative 7. That is vertex form, unless you want to be, picky and have a minus in there. So full vertex form would be 4 of x minus negative 1 squared plus negative 7. That is just so many print. Honestly, this one looks so much prettier, but I don't, depending on whether you're looking for pretty or picky. Yes.
I think at number 22, my brain had a fart.
Okay.
And in the middle of the equation, I had 4x, and for some reason, I then put 2, and then I had plus 3 squared minus 36. I know it's wrong. I don't know why I put the 2 there.
That was a little too complicated to follow, but I get that you noticed a mistake. You can leave a comment on it, I think. Are you able to leave comments on your own assignments? I think you can. Anyway, the vertex is the point negative 1, negative 7. The axis of symmetry is the line x equals negative 1. And since a is 4, it opens up. I had said that I would do one more problem to number 24. However, I essentially have seconds left. So that's going to have to be something for another time.